Welcome back to the Winterberry Wildlife Tech Series. Today I'll be debugging and repairing a Browning Recon Force Advantage which had stopped triggering. In this video I'll go through a little more of my process, including a couple of dead ends, but in the end I did figure out what was wrong and was able to make a repair. So let's get started. A Facebook friend forwarded me this camera after trying to have it repaired by Browning. The Browning tech reported a detection issue, which they were unable to repair. When I turned on the camera, I found that the screen and menu system all worked fine, but the camera would not trigger at all. To isolate the problem, I put the camera in the motion test mode. No matter how much I waved my warm hand in front of the PIR sensor, the aim test LED never illuminated. This narrowed the problem down to the PIR sensor and its connection to the processor. I opened the camera up, exposing the main circuit board. I could see evidence of water incursion almost immediately. The back side of the main circuit board and the IR flash circuit board were covered with a thin sheen of white oxide. Several of the parts had green copper oxides around their metal contacts, including, foreshadowing, pins 19 and 20 of U15. We'll get back to those later. I started by cleaning the circuit boards with a cotton swab and isopropyl alcohol. It looked a little cleaner when I was done, but when I turned it on to test, I got the same behavior. My next thought was that the sensor itself had failed. It also had some oxide on the IR window. I'll admit, this was a long shot. The PIR sensors in this camera are quite robust and encapsulate all the sensitive analog and digital electronics needed to turn the very small signal from the pyroelectric sensor into a logic level trigger signal. But I plan to proactively do my fix for run-on triggering, just in case, and that fix requires desoldering the PIR sensor from the circuit board, which is most of the way to replacing it. I installed a replacement PIR sensor from a parts camera and tested the camera again. Same broken behavior. Wah, wah. My next step was to look more carefully at the PYD 1698 integrated PIR sensor. The spec online gives a block diagram, the pinout, and the communication protocol for this 4-pin device. I confirmed that the power and ground connections were working, then I turned my attention to the 2 signal pins. SEER-IN is used to program the device, and data link is used to read data and trigger information. I started by confirming that the device was being properly initialized and programmed. I tacked on some copper pins to the SEER-IN and data link pads on the circuit board. Then I connected these 2 signals to my USB logic analyzer. Here's the trace I got when I turned on the camera. You can see there are a series of pulses coming in on the SEER-IN pin. Using the spec, I was able to decode these signals and confirm that the device was indeed being programmed correctly. But I also noticed that the data link pin is always high. This is a problem because, as the spec explains, this signal should be low until the device is triggered. Then the signal remains high, triggered, until the microprocessor drives it low. I used a pointy dental probe, which I grounded with a test clip, and briefly drove the data link low. I observed that it would stay low until I passed my hand in front of it. Then it would go high and stay high. But even after I drove the data link low manually, the camera did not trigger when I passed my hand in front of the PIR sensor and the data link signal went high. This all confirmed that the PIR sensor was working correctly. It also suggested that the connection between the data link signal and the camera's processor had failed somewhere along the line. I was able to find a small test point labeled TP52, which connected through a 200 ohm resistor to the data link signal from the PIR sensor. Fortunately, from an earlier project, I had an extra known working main circuit board for a Browning Recon Force Advantage camera. I used it as a reference to figure out where the data link signal was supposed to go. I set my digital multimeter to continuity test mode and placed the tip of one probe on TP52. With the aid of a dissecting microscope, I was able to follow the super thin copper trace from the test point a short distance on the circuit board until it disappeared under U15. I then pressed the second probe of the multimeter to each of the 20 pins on U15. When I hit pin 19, the multimeter beeped, indicating a connection between the test point and this pin. Armed with this information, I went back to the circuit board from the broken camera. I put the tip of one probe against TP52 and the other against U15 pin 19, and nothing. No continuity. At last, I had found the problem. The moisture in the camera, driven by the small voltage required to keep the PIR sensor active, had corroded away the trace between the PIR sensor and U15, leaving it an open circuit. Without this connection, the camera's microprocessor could neither sample nor reset the data link pin from the PIR sensor, and the camera wouldn't trigger. All I had to do now was to restore this electrical connection. To do this, I unsoldered and lifted pin 19 from U15, then I stripped the insulation off of the ends of the small length of fine-gauge wire rack wire. I soldered one end to pin 15 and the other to the surface mount resistor near TP52. This effectively replaced the corroded-away circuit board trace, allowing the processor to see the data link signal from the PIR sensor. Having made this fix, I turned the camera on and set it to motion test. Lo! The aim test LED lit up when I passed my hand in front of the PIR sensor. I also confirmed that the camera triggered and would take photos and videos. This camera works great now, but we did get lucky. If the corrosion damage had been more expensive and caused multiple failures, finding each one of them would have been a lot harder. If any one of them couldn't have been fixed with a simple wire patch, I'd have been up the creek. I hope you enjoyed this compressed debug session. Thanks for watching. Be sure to hit subscribe for more technology that will help you get more from your camera traps.